Hello, everyone. Welcome back to episode 4 of me learning C++. I first want to just thank everyone for taking the time to watch these videos and subscribe. It looks like we are already at over 100 subscribers, which is super awesome. And I'm glad that there's people out there that find this sort of content interesting. I also wanted to thank this viewer from last video who left a really kind comment. And I thought that this was very useful to read through. Because they provided some sort of corrections slash just more context for some of the stuff I was talking about in the last video regarding pointers and memory. So I won't go through everything that they said here, but I think I can talk about maybe some slight corrections or rewording of what I was talking about last time, thanks to this person, and also what I looked up on the internet. So I think for the first thing, in the last video, I tried to declare, like basically create a pointer variable with this sort of syntax, which was like a type with the pointer star, and I'm calling this pointer p. But actually what's happening behind the scenes here is this is telling the compiler or the program to basically just grab any random piece of memory. And this is bad because if that memory address happens to be like taken by the operating system or some other program, and I try to dereference and manipulate that memory, it can result in a crash because there are certain memory addresses or spaces that are protected, and you shouldn't be modifying them. So in the case where in last video I compiled and ran this program and it actually ran fine, I basically just got lucky, and eventually if this program or this sort of syntax is used widespread, it will eventually result in I guess what we call undefined behavior or a program crash. So this sort of thing you want to avoid doing. And instead, it's probably better to declare and initialize your variable it's kind of like this, doing like int x equals some value. And then if you wanted to grab a pointer from this, then you can use the address of operator to define a pointer variable. Because in this case, this line is actually the memory that's allocated to store this variable's data is known to be safe because we're telling it we need to store 10 here. So this cannot be like an invalid memory address, basically. I also saw that there's maybe a newer way of initializing variables, which is this X like bracket notation, which I think is used in modern C++ and is actually recommended. So instead of using X equals 10, you can use the name of the variable and this bracket notation to set the value of that variable. Yeah, I might be using that in the future, but I think that's recommended for modern C++. But anyway, once you have declared and initialized your variable, then you can grab the pointer with this notation. So I wanted to clear that up from last time. The other point the commenter made was that in my last video, I mentioned that having a function like this add function and passing in the variables by copy or by value, I mentioned that that was inefficient, but that actually is probably not correct, and it might be preferred or more performant to actually pass these primitive type variables by value. There's probably many reasons for that related to how the compilers work and CPU architecture and how they deal with creating pointers. But basically for these primitive types, I think it's probably recommended for you to be passing in things like ints, floats, and bools and stuff by value instead of by reference. When would you want to pass in a variable by reference? I think there's maybe a few different cases, but maybe the most general rule of thumb is if you're passing in like a class object that has memory allocated to the heap, it might be preferred to pass that in by reference. Or maybe another way of thinking about it is if you just have a larger piece of data or something that's going to take more memory, you would probably want to store that on the heap due to the stack's limited size. The other reason would be if you wanted to modify the variable within the function that you're calling, you would have to pass that value in by reference. Okay. And maybe the other thing was I have another project here. So I made a mistake when I was talking about how to basically make new objects and allocate them on the heap. But let me just read through this code really quickly. So I defined a very simple class called car, and this car basically just stores two variables, or two member variables. The first is a string, which is the brand of the car, and the second is the year of the car as an integer. And we have a constructor here that is taking in these two inputs, the brand and the year. And this is another kind of newer form of syntax for class constructors. It's called the member initialization list. And it's actually a way to set the value of these member variables before, I guess, this constructor is even called, so that we don't waste time having to set the value of them inside the constructor function. I don't know if that made any sense, but I think this is just the preferred way of setting those variables when you create an object, because the constructor is called whenever an object is created. Anyway, in my last video, I made a mistake when I was talking about how to allocate the object onto the heap. But basically, this is the fixed syntax. The thing I forgot is that when you use the new operator to create an object, this new operator actually returns a pointer of that type instead of like the object itself, I guess. So I had forgotten to name my type car pointer, and I was getting a linting error because it was saying there was some sort of type mismatch. But what actually happened was I just forgot this pointer notation. So in my main function here, I'm showing two ways of declaring or creating a new object. And this first way is going to be allocating car1 on the stack. Second way is allocating car2 on the heap. So I think I can probably draw a diagram illustrating what is going on here. But essentially, if you're creating a new object with this sort of notation and calling the constructor by passing in these two inputs, if you're not using the new operator, this is going to allocate this variable and its memory on the stack. If you're using the new operator, this car object's data will be stored on the heap or allocated in the heap memory, while this pointer variable that we are creating will actually be stored on the stack. And again, I will probably try to draw a diagram about this, but the way that memory leaks happen is since stack memory goes away once the current function scope is closed, or basically at the completion of a function, since this pointer is the thing that is stored on the stack, if the pointer gets deleted, we're not going to be able to actually delete the memory that is still being stored on the heap for this object. So that's why they talk about manual memory management. If you are using if you're using heap memory, you need to actually remember to free that memory by using the delete keyword and deleting this car2 on the heap before the completion of this main function's execution. So let me try and draw a diagram to explain what I'm saying here. So there are probably different ways of drawing representing memory visually, and I think stacks are usually going from the bottom up, and heaps are drawn like top down. But for simplicity, I think I'm just going to draw kind of horizontally like this. So let's assume that this great green box kind of represents our memory, or our RAM, and this is the memory that a program can basically use during its execution. And memory, the available memory is kind of divided into different sections, but for now I'll just be talking about heap and stack. And I think, as we learned in last episode, the heap is there's actually more memory available in the heap, and the stack is actually quite small. I think in the range of 1 to 8 megabytes. And I'm assuming heap will be much larger than that. And so basically what happens is when you call functions, when a function is called, it actually gets added to like the function call stack, and that can be stored in the stack here. Same with variables that are declared inside of a function call. They will be stored on the stack. And as soon as a function is returns or is completed executing, that gets popped off of the stack, and that memory is cleared and available to use again. So in the case where we define a variable like int x, let's say int x equals 10, what I'm saying is the memory for this variable will be stored on the stack. Now, in the case that I was just talking about, where we have a choice with, I guess, with class objects mainly, we can actually choose to create the object and store its data either on the stack or on the heap. So what I just said was when we use the new operator, what happens is a pointer to that object gets created on the stack, but the object itself and its memory gets stored on the heap. So if we were using the car example, we would have the car and its year and its brand, I guess, would be stored like on the heap, while its pointer would be on the stack. And the problem is when the scope of the function, or when the function that we called this, that we created the pointer and object in completes, this portion of the stack will be deleted and freed for further use. But if we forget to free the memory on the heap, this memory never gets unallocated, and it actually, it's just basically you can't use it again. So if we were to call if we were to create many objects, many car objects, they would eventually start taking up a whole bunch of space on the heap if we forget to free that memory. And this is what is basically, this is a memory leak. This is what happens. And there's basically no way to free this memory up until your program basically terminates or like it crashes because your computer has no more RAM available. In contrast, if you don't use the new operator and you just create an object that is stored on the stack, this memory will automatically be freed at the completion of this function call. But the limitation is if you have like large data that needs to be stored, the stack might not be able to store it because of this size limitation. So that's when you would probably need to allocate it to the heap. And this concept is, it's basically the majority of what memory management means. In modern C++, there is smart pointers, which actually, it automates the freeing of this heap memory for you. So I think that's basically the main concept with smart pointers, is that you don't have to remember to free the heap memory before like your function call completes. So smart pointers still return a pointer that's stored on the stack, and it stores the object memory and data on the heap, but it just remembers that it needs to clear that data from the heap when you are done with that object, basically. And I'm sure my understanding of this will evolve as I learn more about C++. And off camera, I also wanted a way to kind of visualize how memory leaks kind of occur, basically. So I had Gemini kind of help me write a little demonstration. So basically, I'll kind of explain what's going on here. We have a function called createLeak. And what this does is it requests, it basically creates an array, a large array of integers, and it's using the new keyword, which again means it's allocating this array on the heap. And this is a 10 million, an array of size 10 million integers. Now this step 2 is us basically assigning values to each of those like allocated memory blocks or each element in the array. This is necessary because actually I tried it without this, and the compiler actually was smart enough to notice that we're not actually doing anything with this allocated memory, and it didn't result in a memory leak. So that's why we have to actually put some values inside of this array that we've allocated. And then we're just printing to the console what's going on. And in our main function is where we actually call this create leak function. And we're going to do this 1,000 times, or basically up to 1,000 times. We're going to call create leak, which again is going to allocate a new 10 million size array on the heap. And notably, we're not clearing the heap memory every time that we create a new like array on the heap. So this will result in a memory leak, meaning like the heap will start filling up, and we're basically going to see that our memory usage for this program will like start spiking up, which I'll demonstrate in a second. This line of code is just going to add a 20 millisecond delay between each of these creations of these arrays, just in case it like, if we don't do that, it might crash the PC if the RAM usage spikes too quickly. And that's basically the whole function, or the whole program. So if I go and if I remember where this was, I think it's, yeah, it was in the same directory. So if I go ahead and compile this memleak .cpp file, and then I will open up our system monitor. So the system monitor is just showing the usage of RAM, basically, or memory on my machine. And right now there's about 3.5 gigabytes out of 8.3 gigabytes being used. And we'll see that if as soon as we run this program, we should see that the memory usage will start spiking up. So we see this red line, and we can see that the usage of memory is going up quite quickly. It looks like it kind of topped out, but as soon as I terminate this program, once the program is executed, then the operating system, I guess, will be able to free that memory that was being taken up by all of these like empty arrays on our heap. Yeah, so that's basically an illustration of how what it looks like when there's a memory leak in your program. So this is something you obviously want to avoid by making sure that we clear this heap memory before we're done using it. Okay, cool. Thanks everyone for watching, and we'll see you next video.